Z-score for a sampling distribution. First of all, in this video, I'm going to talk about how we compute a Z-score in case of a sampling distribution, and then we are going to take some examples to see how the sampling distribution, how the theory of sampling distribution can be applied in a real-life situation. So let's first start. We already seen this one. If we have a single data point, then we can find the z-score by using this particular formula. We have z equals to the formula we already used several times. You take the raw score, you subtract the mean, and you divide by the standard deviation. That's the formula you use when you have a single data point. But what happens if instead of a single data point, we have a mean or group or a sample values? Then what the formula we use? We use this particular formula. We have z equal to, write the same fraction, but now in place of, we don't write x here, rather in its sampling distribution, our variable is the sample mean. So we write x bar. And then we subtract the mean of the sample mean, that is mu of x bar, and then we divide by the standard deviation of the sample mean. This is also called the standard error, right? This is the formula we use when we have a sampling distribution, when we have to find the z-score for a sampling distribution. But note that in this formula, these two values can be used. We have a relationship for these two values. For example, we know that the mean of the sample mean is always equal to the population mean, and the standard deviation of the sample mean is always equal to the standard deviation of the population divided by the square root of the sample size. These are the two relations that do exist due to the central limit theorem. I hope you remember that. Due to CLT. If the condition of the central limit theorems are met, then these two relationship do exist. So what I'm going to do now, in place of this one, I'm going to replace the values. So let's see what are the values we're going to have. There's no change in x bar, minus, in place of the mean of the sample mean is equal to the population mean, I'm going to put a mu here, and whole divided by, I'm going to put in place of this sigma x bar, I'm going to put this relation. This is sigma divided by the square root of the sample size. So in short, we know that if we have a sampling distribution, then the z-score can be found by using this particular formula. X bar minus mu divided by sigma divided by the square root of n. This is the formula which we are going to use. This is the formula we are going to use when we have to find the z-score for a sampling distribution, and this is the formula we are going to use when we have a single data point. A single data point, we use this formula to find the z-score. So this is very important that you understand in which situation which formula to use, and we will see the application when we see the real life example. So let's see some examples. So I have two examples here, example 1 and example 2. And I have written these two examples. You might be wondering why I have written these two examples side by side. So what I want from you guys to pause this video and pay attention and tell me what is the difference between these two problems, how these two problems are different, right? So this is very important that you read the first example. I will solve both of these examples, but what you guys need to point out, what is the basic difference in this example and in this example. So I ask you guys to pause the video and then tell me the difference. So let's read the first one. Assume that the salaries of an elementary school teacher in the United States are normally distributed with a mean of $32,000 and a standard deviation of $3,000. If one teacher is selected at random, find the probability that his or her salary is less than $32,500. Look at the second problem. Assume that the salaries of elementary school teachers in the United States are normally distributed with a mean of $32,000 and a standard deviation of $3,000. If 100 teachers, look at that, 100 teachers, if not one teacher, but 100 teachers are randomly selected, find the probability that their mean salary, look at the mean salary, look at, find the probability that the salary of one person, look at this one, the randomly selected person. Here we are talking about the average salary, the mean salary of these 100 people is less than 32,500. So my dear student, the first problem belongs to a normal, this belongs to a chapter number 6 problem. It doesn't involve the sampling distribution, but the second one, the second problem, it belongs to the sampling distribution. Why? Because the variable under consideration here is the mean salary. So we will solve these two problems one by one to clearly understand the difference. So let's solve this. Let's see the first example. Assume that the salaries of elementary school teacher in the United States are normally distributed with a mean of 32,000 and a standard deviation of 3,000. If a teacher is selected at random, find the probability that his or her salary is less than 32,500. So the salaries are normally distributed. We will start this problem by drawing a bell-shaped curve. Let's draw a bell-shaped curve. Let's take a bell-shaped curve. Here we are. We're going to start this problem by drawing a bell-shaped curve. That's better. Exactly in the middle, write the mean value, that is 32,000, and also indicate the standard deviation, which is 3,000. Now what next step is? The next step is you locate the value of your interest. The value of my interest is this one, 32,500. So 32,500 will be somewhere here. Once you have located this value, what you do, you build a wall like this. This is the value which we are calling, this is the value 32,500. Okay, 32,500, this is the value. Now by drawing this wall, my graph is divided into two portions, portion 1 and a portion 2. Why I number these portions? Because I want to shade one of these portions. Which portion I'm going to shade, it will be told to me by the problem. And the problem says find the probability that his or her salary is less than 32,500. All the values on this right side are more than 32,500, and all the values on this left side, which I'm drawing here, this one with a solid line, this is less than 32,500. So clearly we will shade the region 1 and not the region 2. So this is the purpose, this was the reason that I give the number, so that I want to show my students that this is the area that needs to be computed. Right? This is the area. Now why I'm shading this? Because I want to draw the attention of my student that this is the area that needs to be computed. So you know, in order to find the area, we always go to the table, right? And we're going to use the table, right? How we're going to use the table? We cannot directly use the table. Why? Because this is a non-standard normal curve. This has to be converted to a standard normal curve in order for us to use the normal distribution for a normal distribution table. So what I'm going to do now, I'm going to first convert this non-standard normal distribution into a normal one. Right? So we have, this is our raw score. This is our x value. So we're going to use this formula. This is a single value. So x minus mu over sigma. So this is equal to 32,000 500 minus 32,000 divided by 3,000. So we have 32,500 minus 32,000. It's a 500 divided by 3,000. So these two cancels out. 5 ones are 5, 5 6 are 30. It's 1 divided by 6. So the z value comes out to be 0.17. This is the z value we get. So what we do now, we go to the table and find this particular value. So we have a z-score of 0.1. I hope you remember that, how to check the table. We have a z equal to, how are we going to do that? 0.1, and I'm going to write this 7 with a different color just to draw your attention. So let's go back, and we have here, look at that, this is a 0.1 and a 7 here. Look at that. This is the value we're going to find, and the value is 0.5675. Look at that. From here 0.1, and from the top 0.07. So this is 0.5675. So 0.5675. So the area comes out to 0.5675. So that's the area. That's the area comes out to be, right? That's the area that comes out to be. So once we have converted this into a z-score, remember, once we have converted this raw score into a z-score, then we were in a position to use this particular table. So if we randomly select a person, a teacher in this situation, there is a 56.75% chance that his or her salary will be less than 32,500. I hope you understand. This was a similar problem. We have done this problem in the previous chapter, in chapter number 6, when we were talking about the non-standard normal distribution. So you might be wondering, there is nothing new. The new thing will come into play when we see the next example. So let's see the next example. Now let's see the second example. Assume that the salaries of elementary school teacher in the United States are normally distributed with a mean of $32,000 and a standard deviation of $3,000. If 100 teachers are randomly selected, find the probability that their mean salary is less than 32,500. I told you, as in our previous discussion, that this is a problem that deals with the sampling distribution. What is the reason for that? It's not a single value. We're talking about 100 teachers. We are selecting a sample of 100 people, and we want to find the probability that their mean salary. So the variable under consideration is here the mean salary, the average salary, right? So what we are going to do, again, we're going to start in a similar fashion. We're going to draw a bell-shaped curve. Let me draw a bell-shaped curve. Here we are, the bell-shaped curve. Exactly in the middle, write the mean value. Mean is 32,000. And the standard deviation of 3,000. Now look at the value of your interest. The value of our interest is 32,500. This is a value somewhere here. It's a mean value. It's somewhere here. Once you have located this value, then what happened? You built a wall like this. This is the value. By building this wall, our graph is divided into two portions, portion 1 and a portion 2. Let me indicate this value. This value is 32,500. Now, it's very important that you understand one thing. Let me change the color of this axis. In this figure, this axis is represent the sample mean. This represent X bar. This is very important that you understand. This is the sampling distribution. So this is the average salary. This axis which I'm putting in red now on the top of the green one, this is X bar. Recall from our previous example, this was X, this was X axis, this was X value. In my previous example, if you remember, this was my X value, this was my X value. But look at here, in this example, this is my X bar, right? So this is very important that you understand. Another difference, let me show you the difference here. Here the mean also changes. It's a mean of the sampling distribution. So it will be mu of X bar. And at the same time, it is the standard deviation of the sampling distribution, sigma of X bar. I never wrote these two things intentionally just to draw your attention that, that you guys realize this, that now the mean, this is the sampling distribution. So this value will be the mean of the sample mean, and this will be the standard deviation of the sampling distribution, right? So this is very important we understand this thing. This is very, very important that we understand this particular thing. Okay, so once we have numbered these two portion, the idea is to shade one of these portions. Which portion I'm going to shade, it will be told to me by the problem. The problem says that their mean salary is less than 32,500. So all the values on this side, are greater than 32,500, and all the values on this side are less than 32,500. So I'm going to shade again as in the previous problem in this area, and that was the main reason for numbering these portion, so that I want to draw your attention that this is the area that needs to be calculated. So this is the area that needs to be calculated. But there is a problem. The problem is that this is a non-standard normal distribution. The mean is not 1, the standard deviation is not 1. It's a non-standard sampling distribution. So first what we have to do, we have to convert this non-standard normal curve into a standard normal curve, and we have to apply the transformation. We already learned a transformation, and the transformation is z equals to X bar minus mu of X bar divided by sigma over the square root of the sample size. I hope you remember from our earlier discussion we did that, right? We did that already. So let's plug in the values. The sample mean is 32,000. So this is the value. This needs to be corrected. This value has to be corrected. This is not 32,000. This is 32,500. Sorry for that. 32,500. The sample mean minus. This is mu of X bar is equal to 32,000. This is 32,000. Divided by the standard deviation. This is 3,000. Divided by the square root of the sample size. The sample size is 100. 100 people are randomly selected. This one. We're going to do some computation here. 32,500 minus 32,000 is the 500. Simple calculation. Divided by, this is 3,000. Divided by square root of 100 is 10. So this cancels out. So I'm left with 500 divided by 300. This also cancels out. 5 divided by 7. So the z-score comes out to be 5 divided by 3, not 7. 5 divided by 3, and that is equal to 1.67. That's the z-score we have computed. That's the z-score we have calculated. Now what we are going to do now, we're going to look this value in the table. Now we can use the table. Previously we were not able to use the table here. We were not able to use the table because it was a non-standard normal distribution. Now we can use the table. Okay, so what I'm going to do now, I'm going to write z equals to 1.6, and let me write this with a different color just to draw your attention. This is 1.67. So what we are going to do, we're going to look this 1.6 in this z column, and a 7 is 100 position, the top row. Let's go to the table. Look at this one. This is 1.6 here. Go all the way, and the top 0.7. So the answer comes out to, the area comes out to be 0.9525. 0.9525. So the area of the probability comes out to be 0.9525. This is the area or the probability. And I told you the area of the probability, same thing. So this is equal to, this can be converted into a percentage, 95.25%. So if we randomly select a sample of 100 teachers, there is a 95.2% chance that their average, the mean salary, will be less than 32,500. So this is very important that you guys interpret the result in a way so that the common people can understand. I hope you understand this portion, and thanks for watching.